All right, in this session, we'll take a look at the 6 trig functions. And we're going to begin with cosine and the cosine of theta. And this symbol you see here, this is called theta. And in trigonometry, just as in algebra, we use variables. However, in algebra, we use Arabic variables, letter variables, A, B, C, D, X, Y, Z normally. In trigonometry, we use letters of the Greek alphabet. So these are still unknown quantities variables. So we have the cosine of theta is equal to x over r. The sine of theta, and theta is just some unknown angle. That's equal to y over r. The tangent of some angle is equal to y over x. And then we have the reciprocals. The reciprocal of cosine is secant, and that is r over x. The reciprocal of sine is cosecant, and that's r over y. And the reciprocal for tangent is cotangent, and that's x over y. Also, some facts that follow the 6 trig functions. R is always positive, right? So greater than 0 means positive. And then we also have the Pythagorean theorem. R is equal to the square root of x squared plus y squared. X is equal to the square root of r squared minus y squared. And y is equal to the square root of r squared minus x squared. Okay. So we'll see some examples where we have to find x and we have to find y, so we'll use one of the two formulas. Next, I want to go in and I want to pull up the unit circle. Right, and here we have the unit circle. And just one thing about the unit circle, notice that it's just a circle with a radius of 1. Right, so you'll see at the top it says that r squared is equal to 1. So let's say if we wanted to find the cosine of 30 degrees, right, so I want to just minimize that for 1 second. If we're dealing in the unit circle, and now just as in ordered coordinate system, which the x and y, in which the unit circle is, we have ordered pairs x comma y, if you remember from algebra. We still have ordered pairs, but in the unit circle, the x coordinate is the cosine of some angle. The y coordinate is the sine of some angle. So for example, if we wanted to find the cosine of 30 degrees, right, I would simply locate 30 degrees and I would look at the x coordinate for 30 degrees. Right, so going back to the unit circle, I want to find the cosine of 30 degrees. So here I have 30 degrees, which is the same as pi over 6 radians. I'm going to look at the x coordinate, which is square root of 3 over 2. So we have square root of 3 over 2. Let's say we want to find the sine of 3 pi over 4. Right, so I would find 3 pi over 4. And since I'm looking at the sine, I will look at the y coordinate. So again, if I pull up the unit circle, right, I would have 3 pi over 4, which is 135 degrees. I'm going to look at the y coordinate, which is the sine, and I have square root of 2 over 2. Another place you can find or you can evaluate trig functions, and I'm going to go back to our main page in Blackboard. I'm going to go into formula sheets, and I'm going to use this unit circle function values chart. And in this chart, it gives me it evaluates the 6 trig functions for every angle in the unit circle. So for example, if we wanted to find the cosine of 30 degrees, here we have it as square root of 3 over 2. If we wanted to find the sine of 135 degrees, which is 3 pi over 4, we have square root of 2 over 2. We could also use this chart to find, let's say, the cotangent of pi over 6. Now, just one thing about the unit circle, the only values in the unit circle are sine and cosine. Okay, in order to find the tangent, you have to put the y value over the x value, and you would have to rationalize your denominators. You could also find the reciprocal of sine, which is cosecant, by simply reciprocating, and you can also find the secant by reciprocating. But you can more readily find those values using this chart. All right, so if we wanted to find the cotangent of pi over 6, we would simply find pi over 6, right, which is 30 degrees, and the cotangent is the square root of 3. Right, so the cotangent of pi over 6 is the square root of 3. Okay, and we'll do one more. We could also find, let's say, the secant of 210 degrees. So again, I'll pull up the chart. I can find 210 degrees, which is here. I can go over to the secant, which is negative 2 square root of 3 over 3. So now we'll take a look at the next example. If the cosine of t is equal to 3/5 and t in quadrant 1, then we're asked to find the following: the sine of angle t, the cosine of angle t, the tangent of angle t, and then we're going to find the reciprocals. The reciprocal of sine is cosecant t, the reciprocal of cosine is secant t, and the reciprocal of tangent is cotangent t. Okay, now you'll remember from our quadrants, right? This is quadrant 1, quadrant 2, quadrant 3. in quadrant number 4. So all of our angles are in standard position. So here again, standard position means that they all start along the positive x-axis. And our terminal side is in the first quadrant, which is 3/5. So I'm going to plot a point, just an arbitrary point in the first quadrant. I'm going to drop a perpendicular. Okay, you always drop your perpendicular to the x-axis. So here we have an x, we have a y, and we have a r. Okay, so keep in mind that r is always positive, right? So this is what we're given. We're given that the cosine of t is 3/5. Okay, so if we go back to our formulas, the cosine is equal to x over r. Right, so we're going to substitute 3 for x, right? So this is our cosine value, 3/5. So we're going to substitute 3 for x and 5 for r. Right, so x is 3 and r is 5. Right. So I know that my cosine value, which was given, is 3/5. I can also find the reciprocal of cosine, which is secant, right? So the secant value is 5/3. Now, in order to find anything else, I need to know y. So in order to find y, I'm going to use that formula. Y is equal to the square root of r squared minus x squared. So r is 5. We're going to square that. Minus x is 3. We're going to square that. So we have 25 minus 9, which is the square root of 16. So y is going to equal to 4. Right. So now we can fill in the rest of our values. So the sine is y over r. So that's 4/5. Cosecant is the reciprocal of sine. So we can write the cosecant as 5/4. The tangent is y over x. So the tangent is 4/3. And the cotangent is the reciprocal of the tangent. So the cotangent is 3/4. Now, if we're asked to evaluate trig functions using a calculator, we're going to use the following functions. So I'm going to go back to the Blackboard homepage, and I'm going to pull up this all exam formula sheet, and I want to concentrate on the reciprocal formulas. Right. So now we have a sine, a cosine, and a tangent function in the calculators. So I'm going to pull up my calculator. Right, so we can see that in our calculator we have a sine, a cosine, and a tangent. Now the reciprocal of sine is cosecant. This sine to the negative first power, this is not cosecant. This is an arc sine, and they are used to find angle measures, right? But we do have a sine, a cosine, and a tangent function on the calculator. So I'm going to go into the, turn it on, and In this class, it's going to be important the mode that you're in. Okay, so I'm going to click mode, and if I go down to the third line, I have a radian mode and I have a degree mode, and you want to be careful which mode you're in. The mode you're in depends on which degree measure you're given. You can be given the degree measure in radian, so you want to make sure you're in radian mode to evaluate, or you could be given the degree in degree mode, and you want to make sure that you're in degree mode in order to evaluate. So here is an example. The cosine of 30 degrees, we're going to evaluate with the calculator. Since we're given the angle measure in degrees, we want to make sure that our calculator mode is in degrees. So I'm going to hit the cosine of 30. I'm going to close off cosine, and we have 0.866. Now, if we were in the wrong mode, so I'm just going to show you what happened. If I'm in radian mode, and now if I were to put in the cosine of 30, notice I'm going to get a totally different value. Right? So you just want to make sure that you're in the right mode. Right? So if, let's say, we wanted to evaluate the cosine of pi over 6, I want to make sure that I am in radian mode, which I am. I'm going to put in the cosine, and I'm going to use pi. And pi is above the caret, and it's a yellow function, so I'm going to hit second, and the caret, which is pi, divided by 6, and we should get the exact same value, right, 0.866. All right. So let's just say we wanted to find the tangent of 15 pi over 8. All right, so again, you just want to make sure you're in the right mode, and I am in radian mode. So I want the tangent of 15 pi divided by 8, and we have negative 0.414. Okay, now let's say we were asked to evaluate the secant of 75 degrees. So in order to evaluate the reciprocal functions, we want to utilize the reciprocal identities. For example, the cosecant of some angle is equal to 1 divided by the sine of that angle. The secant of some angle is 1 divided by the cosine of some angle. And the cotangent of some angle is 1 divided by the tangent of that angle. So in order to evaluate the secant of 75 using a calculator, I must put it in as 1 divided by the cosine of 75 degrees. So on my calculator, I'm going to go into mode. I'm going to make sure that I am in degree mode. I'm going to put in 1 divided by the cosine of 75 degrees. And we have 3.864. Next, I'll evaluate the cosecant of 3 pi over 4. So again, I'm going to use the reciprocal formula, and I'm going to put into the calculator 1 divided by the sine of 3 pi over 4. So I want to check the mode on my calculator. I want to make sure that I am in radian mode. Now I'm going to lock that in with enter. I'm going to put in 1 divided by the sine of 3 pi divided by 4. and we have 1.414.